Welcome to this video, where we will be discussing line of sight, overlapping data, what it is, and how it affects your iGUIDE as a final product. Chapter 1. Line of sight. First of all, what is line of sight and why should you care about it? Let's start with why you should care. Having line of sight means that your life is made easier and your workflow is faster. Without line of sight, you are forced to manually align the data in Survey or Stitch. Misaligned data is likely to be rejected by your drafting team. Line of sight refers to a straight line along which an observer has an unobstructed view between 2 points, and without it, your data cannot auto-align. The left image is portraying no line of sight within a space, whereas the right image shows the correct method to capture this space. A good way to confirm line of sight whilst shooting an iGUIDE is to be able to see the last location or locations where you processed a scan. As long as you can see the previous scan location, the line of sight requirements are being met. This will allow our system to auto-snap the data and provide improved navigation within the iGUIDE. When scanning an entire property, for example A on screen shows enough scan coverage, but not enough line of sight for reliable overlapping data. Nor will this allow the end viewer to experience the iGUIDE to its full potential. A critical consequence of not having line of sight is that while on site, the auto-align tool will not function as intended. This will result in additional time requirements on your end when aligning the data in Stitch. In a worst-case scenario, the data itself may be rejected, delaying the processing of your iGUIDE altogether. In this example, you will see the scans indicated as red dots. The first scan is taken in the foyer, and the second scan is taken in the living room, but with no line of sight to the first scan. Within the virtual tour, the walkthrough experience is negatively affected because the user will end up clicking through a wall in order to navigate between each scan. Example B on screen shows adequate scanning locations of a property, where each scan location has, at minimum, one scan within line of sight and in many cases, multiple. As you can see from the below image, the scans have an excellent level of line of sight and would therefore provide an excellent user experience through the 3D navigation, as well as provide ample overlapping visual and laser data. It's always a good idea to plan out your scan locations so that you can ensure line of sight at the same time as documenting a space. For example, by moving point A to location B and filling in that space, point C, we have provided a line of sight through the bottom kitchen walkway into the hallway. Line of sight is one of the most important parts of shooting an iGUIDE, including keeping room doors open, opening closet doors and bathtub curtains for documentation purposes. Secondary to line of sight would be overlapping data and data density. This brings us to Chapter 2, Overlapping Data. What do we mean by overlapping data? In simple terms, overlapping data is where the LiDAR has captured the same wall surface multiple times. Capturing overlapping data will also allow the system to auto-snap, also known as auto-align. This will auto-align your scans, saving you time on-site and reduces post-processing efforts in Stitch. Overlapping data works in a similar way to assembling a jigsaw puzzle, where each scan can be thought of as a jigsaw piece. The correct coverage of data will allow connecting room scans to snap into place. This is how our auto-align feature within Survey works. If there's a high overlap percentage, our system will place this for you. If you do not have the proper line of sight, overlapping data may be insufficient, meaning that we may not be able to perfectly represent the layout. When you add the missing piece, everything makes sense, and accuracy is greatly improved. As you can see in the video on screen, a classic example of no line of sight is when a door is left closed. In this example, we can estimate where the data is placed, but nothing can be confirmed as there's no way to overlap the data. When we introduce a third scan, bridging the void in data, the scan data can be easily aligned. Chapter 3. Examples and benefits. This section will explore what your data will look like when there is no line of sight due to obstructions or incorrect camera placement. One of the most common cases of this will occur when a door to or from a room has been closed. In example 1, we can see how bridging the gap in data by opening the door and filling the gap allows the correct placement of each scan. Open doors also allow a more fluid walkthrough experience within the virtual tour once completed. In example 2, we have no idea how to connect the hallway to the bathroom. In order to solve this issue, we take a scan with the door open, which clearly shows data from the hallway and the bathroom. This allows us to bridge the void between the hallway and the bathroom, as there is significant overlapping data. There may be times when you don't have line of sight, but you may still have enough overlapping data to snap or auto-align the data into place while on site, or when using Stitch. However, the navigation experience may not be as intuitive as scans would appear visible through walls when the iGUIDE has been processed. For example, when you are in an L-shaped hallway and take a scan in one end of the hallway and then another scan at the other as you've turned the corner, you may have enough laser data to snap it together, but when navigating the tour, you will see the scans through the wall. The best method would be to have a scan in a connecting point, ideally the corner portion of the hallways, where that scan can see the other scans in the adjacent hallways. As you can see in the following example, the scans are not very visible through the doorways, limiting the paths that you could take in person. This makes the tour less intuitive for the end user. Navigating through walls can also limit which scans are displayed in the forefront of the 3D tour, which isn't ideal. The second example here shows how easy it is to navigate a 3D tour when the line of sight rule is observed. The ability to look into a room clearly before entering follows the same process as an in-person experience. Again, let's take a quick look at the tour where we travel through walls. In the video on screen, we see that going through a wall forces the scan to fade through black, whereas traveling to a scan within line of sight simply fades between the two images, making the transition far more fluid. Here we have provided an example of a floor plan with good versus bad line of sight into the connecting rooms. Simply by changing the placement of the scans without taking more scans, we can ensure that the line of sight rule is followed without increasing time spent on site. Here, we can see another example of how line of sight is not utilized, forcing the walkthrough experience to navigate through the walls. As you can see from example number 2, the same quantity of scans has been taken, yet the placement offers better line of sight and increased overlapping data.